When working with an exponential function, you typically have two different forms for an exponential function. You can have an annual rate and a continuous rate. For an annual rate, the form of an exponential function is y equals ab to the x, where b minus 1 is equal to r, and r is the rate. And for a continuous rate, the form of an exponential function is y equals ae raised to the kx, where k is the rate. So let's look at some examples to figure out what the rate is for each one. First we have y equals 8 times 1.05 raised to the x. Now we want to find the rate, and we want to state whether it's growth or decay. Now this example here is similar to this example, the form here ab to the x. So to find r, we need to find b. So we see that a is 8, because it's the number in the front, and b is equal to 1.05. Now we need to find r, and r is just going to be b, 1.05, minus 1, which will give us r. So do the math, and we're going to end up with 0.05, which is r. But if you want to convert it to something that we can actually use in conversation, we just multiply this by 100 and we get 5%. So we have 5%, r is positive, so we state that this is a growth function with a rate of 5%. Next we have f of x, which just means y, equals 2.1 times 0.91 raised to the x. So again, this is in the same form as the first one, ab to the x. So let's pick out what we know. A is 2.1, b 0.91, and to find r, we're going to do b 0.91 minus 1, which will give us r. Do the math, we're going to end up getting a negative 0.09 for r. And again, to convert that into a percentage, we just multiply by 100, and we're going to get a negative 9% for our rate. Since r is negative, we say that this is a decay equation. So when r is positive, it's growth. When r is negative, it is decay. Next we have y equals 3.9 e raised to the 0.81x. So this is the continuous form here, ae raised to the kx, where k is our rate. So k in this case is 0.81. So that is what k is, and if we want it as a percentage, we can just multiply it by 100, and we're going to get 81%. And since k is positive, we say that this is a growth equation. So there's our rate, and there is what it is. Now, just a quick aside, for the other equations we used r for the rate, and for these we used k. K and r are typically interchangeable. Sometimes they use r for it, sometimes they use k. It doesn't really matter the letter it's used, it's still what the number is in that spot. That just makes it the rate. So don't get too caught up on whether they use r or k. It means the same thing. Last, we have g of t equals negative 5.3 e raised to the negative 0.0244t. So k again is going to be the number up here in the exponent. So k is equal to negative 0.0244. And as a percentage, we're just going to multiply this by 100. So k equals negative 2.44%. Since k is negative, we can say that this is a decay equation. And here are how you would tell using annual and continuous rate forms to find the rate for each one.